Alright, let's talk about the rest of this thing. So we know that this thing kind of gets bigger, or what happens when I say x is equal to 0? Alright, I use my calculator, x is equal to 0. It says number, div by 0, exclamation point. It basically is saying, the computer saying, I don't know what's going on when you say x equal to 0. The reason being is because what is the domain of this function? Well, the domain of this function is f of x equals 1 over x. That means x cannot equal to 0. All right, but let's look around 0. Let's get smaller. Like we're going from 3 to 1. Why don't we go like 0.5? So that would be 1/2. I'm sorry. Let me just kind of extend this equation out. All right, so 0.5 gives me 2, because when I have 1 divided by 1/2, take the fraction on the bottom, I flip them over. Let me just show you. If I have 1 divided by 1/2, that's the same as 1 times 2 over 1, which is also known as 2. Which is why this thing spit out 2. Well, let's try 0.25. Okay, it's getting kind of cool. All right, let's go negative 0.5. There we go. Negative 0.25. How's about I go 0.1? Let's see what happens there. Ooh. No. Negative 0.1. Ah, interesting. Let's do negative, or 0.01. Okay. Negative 0.01. Let's try negative 0.001. Oh, okay. Is that where we're going then? 0.001. It goes up to 1,000. So you can kind of see that as this thing approaches 0, it explodes up into infinity on this side, but on the left side it explodes down to infinity. Let's double check that and actually kind of make that true, or not true, but let's explore that. I'm going to go over to my favorite graphing calculator website. Okay, as soon as the internet decides it wants to work, there we go. This is my favorite graphing calculator website. It's pretty simple. I want to analyze this thing right here. As soon as it pops up, there we go, 1 divided by x. X. Oh, look at that. All right, as this thing gets smaller and smaller and smaller, this thing ends up exploding to be bigger and bigger and bigger. That's kind of the exact graph of how it would look. So you can kind of see what we're talking about here. Interesting, huh? All right, let's see. So that's what a vertical asymptote is. All right, what happens when x gets closer and closer to 0 from the negative side? Well, if you look over here on the negative side, x gets closer and closer to 0. What happens with the y value? The y value gets bigger and bigger and bigger negative. So I guess that technically means smaller and smaller and smaller. It gets more and more and more negative. What happens when x gets closer from the positive side? Well, if we're hanging out and traveling along the positive side meaning the right-hand side of 0, then you're going and getting smaller and smaller, approaching 0, but your y value is exploding to become infinity. It goes up and up and up and up. In the space provided, draw the coordinate plane. All right, well, I don't need to draw it because I just showed it to you. All right. How does the appearance of the domain of this graph relate to the function of our rematch function, or relate to any of this stuff? Okay, so 1 over x, that 1 over x, the domain being x cannot equal to 0, means there's like this imaginary vertical line. You can kind of think of, this is what I'm calling a vertical asymptote. So you have your regular graph, right? And then at x is equal to 0, there's this imaginary vertical line. I'm going to make it as a dotted line. That looks horrible. Whatever. It's just this like light line that goes over here. So as x gets smaller, this thing gets closer and closer and bigger and bigger. And then as x gets bigger from the left-hand side, this thing gets closer and closer and more negative. An asymptote is a line that you can approach and never touch. One of the things I think of is this thing called Zeno's paradox. I kind of explain Zeno's paradox as, say that I'm a father, and I actually am a father, and my son gets in trouble, and I say, all right, fine, your punishment for getting in trouble is you have to do this. You have to stand 20 feet away from a wall. Here's a wall, and you're standing here, okay? 20 feet. If you want to come out of timeout, all you got to do is touch the wall. But there's the only rule. The only rule is instead of standing 20 feet, you have to half that. So you have to stand 10 feet. So 1 minute later, he stands 10 feet away. Then 1 minute later, he has to stand half of that. So he's at 5 feet. 1 minute later, he has to stand half of that. So he's at 2.5 feet. Then a minute later, he has to stand half of that. So it's 1.25 feet, or 1 1/4. Then 0.5 and an eighth. I don't know, whatever that is. And then he has to half that and half that. So if he's standing at 10 inches, he has to stand 5 inches, then 2 inches, or 2.5 inches, and so on and so forth. The question is, will he ever actually touch the door if he's only halving it? If you're only going halfway every single time, will you ever touch the door? The answer is no. Technically no, at the molecular level. You're never ever going to reach it. You're going to get closer and closer and closer. Well, that's what this asymptote is doing. This graph, or this x value, you can make it smaller and smaller and smaller, but you can never get it to be exactly 0, because at x equals 0, this thing explodes. And as you get this thing smaller and smaller, and it gets closer and closer and closer, but never touches, this y value is going to go bigger and bigger and bigger, and it's going to explode. Just like on the left-hand side, where as this thing gets closer and closer to 0, this thing is going to get smaller and smaller and smaller, and it's going to be like negative infinity. It's going to also explode. That's what an asymptote is. It's kind of a line that it never gets to there, but it always gets closer and closer and approaches. That's what it is. Zeno's paradox. Go look it up.